So what do? How do we factor that thing?
We, right here. What kind is it?
The difference between two squares.
Yeah, you know the official. I haven't even used that word, have I? I probably should. You know, I don't use the math lingo very much, which in some senses doesn't matter. But then when I had somebody tell me one time, one of my colleagues who was reviewing my class, you know, we do that for each other every now and then. Anyway, and then he told me afterwards, he said, yeah, it's okay you don't use the math lingo. He said, but every now and then you should because their next teacher might, and then they won't know what those words are. So that's true. So yeah, thanks, Joel. This is called a difference of squares. That is the technical name. I call it everything else but that. Yeah, I call it an FL, but it is a difference of squares. And that's the official word. Let me write that down because your other teachers will probably, you might, or you'll read it in a math book or on a show me an example problem or something. Difference of squares, because it's a difference, it's a subtraction of things that are squares. Now you might wonder, squares, that's 2 power. Right, well what that is that's x to the 8th is really x to the 4th twice, isn't it? And u to the 8th is u to the 4th twice. That's why they're calling it squares, because it's something twice, something twice. It's squares, it's a difference. Now why do they use the word difference? Because what if there was a plus sign in the middle? And how would we factor? Right, it'd be called the sum of squares. And we can't factor. Remember, the plus sign wrecks it. Just that one little change. The FL with the plus sign in the middle can't do it, right? Be prime. The answer would just be prime on that one, if there was a plus. Are we all good with that? But the minus, called a difference of squares, can be done. I call it an FL. So how do we do it? What goes in the 2 parentheses for the FL? Well, those two things, huh? X to the 4th. X to the 4th on the left and the left. Because powers add, right? So if x to the 4th multiplied x to the 4th, it would go back to x to the 8th, wouldn't it? And u to the 4th, u to the 4th on the, bless you, on the right sides, because those will add up to be u to the 8th, right? 1 plus 1 minus. Why? Because positive times negative is negative. Good so far, but there's more, huh? This one can keep going and going and going 3 times, I think. So next, what am I going to do with that plus there? Going to leave that one alone because the plus never can go further. So exactly, we just leave that there. But what about this minus? Breaks into 2. Keep cutting it in half, huh? Because this is also x squared, u squared. It's a difference of squares again. It's two things with a minus, huh? So that'll break into 2. And we go x squared, u squared. Again, 1 plus 1 minus, because positive times negative, will be negative u to the 4th. Good so far? And then one more time, huh? This plus and this plus are done, because plus can never go any further, so they'll just stay as they were. But now, finally, this minus, which is again x1, u1, with a minus, right? It's a difference of squares again. It's an FL minus. We can do it one more time. This will be the last one, huh? Because we just keep cutting it in half, don't we, till we get down to the first power. So we go x to the 1, x to the 1, u to the 1, u to the 1, 1 plus 1 minus, because positive times negative is negative u squared, and that's it. How do we know we're done? Well, the first 3 are all pluses, plus, they're done, and then that one's a minus, but he's just first power, so we can't go again. We can't cut him in half again. That's the answer, and that's A, huh? Yeah?
Do we always split power up in half?
Uh-huh, yeah. Yep, no other plan. Always split them in half. Is that good? You okay on that? Just keep, for those FLs, just keep cutting them in half, Jeremy?
So why does it change to a positive on all of them, except the very last one stays?
Yeah, so every time you take whoops, I messed up. Every time you take a negative one, that breaks into a positive and a negative, half the powers.
Okay.
Does that make sense?
Yeah.
Yeah.
I thought it was A at first, but then I was like, I don't know why it would change all positives and then only be a minus at the end, so then that's why I thought it was 9.
Oh, gotcha. Yeah, it's just the splitting, and every time it splits, a negative becomes a positive and a negative.
Right.
right? Because how do you get a negative like u to the 8th? So I'm sure Jeremy's question is good one that many people have. So, right, so we all good with that? How do you get a negative u to the 8th? 1 positive, 1 negative. That's why it splits into 1 positive, 1 negative when it half powers, right? Because positive times negative would be negative. And then after that split, the positive one can't split again. But then you shift to the negative one, and he splits into a positive and a negative. So every time it just splits positive and negative, negative, until you can't half power it anymore, until you're down to the first power. FL. Same all the way through calculus. We do FLs.
You would never have a situation where it would be an odd number power?
We do, but then we just can't FL it.
Okay.
Yeah.
So with an odd number, you can't FL, like if it was.
Right.
If it was cubed instead of.
Yeah, if it's like x cubed minus u cubed, you can't FL it.
Then you could do it.
Actually, there's something really special. That's the one other thing I haven't shown. That's the only thing, which I can't remember if we get it at the end. No, I think it's the next course. You'll get that in the next course. That's literally the only other factoring thing there exists all the way through calculus that you haven't seen.
Then you're also saying that, like, if those weren't variables or numbers, the numbers couldn't divide evenly, you couldn't do it with either, right? They both have to,
Right. If there are numbers in front, the numbers have to be able to do the thing too.
and if not, you can't do it with.
That's right. That's right. Exactly, Joel. Yeah. So like what you said up here in the beginning, if there had been like a 4x to the 8th minus a 9u to the 8th, then we could do it because 4 can break down 2 times 2 and 9 can break down 3 times 3. But if this had been something like a 7, then that would wreck it. I couldn't have even done one step. This one would be prime because the 7 wrecks it. Joel's point is correct. So if there's numbers in front of the letters, they have to be able to break down as well. That's right. Good.
It's just prime then.
And it would just be prime. That'd just be prime. Yeah. Good. You guys have learned a lot of algebra in 4 weeks here. That's good. You got it. You're getting it all down.
See the smoke coming out of it?
It hasn't been that hard for you, I don't think. All right. All those hard word problems yesterday. There'll be a nice little break. Nice to end easy.
More physics equation?
Yeah, more physics. Here we go. The ball is thrown. No. 3/21. Reduce the fraction.
That's it?
See? I'm not kidding. I thought I was exaggerating, huh? Oh, he always says it's easy. It's never easy. That's pretty easy, huh?
Yeah.
So how do we reduce that thing? Most of your calculators will do it automatically. So what do we do? Whoops, gotta get my pen going here. Take 3/21s and just divide it, huh? By 3, 1/7, we're done. That's the whole problem. Reduce that fraction. I like to save the best for last. Or the easiest for last.
That means our final's gonna be easy?
That's right, it's just all this. No. A lot of your calculators, you just want to put it in that way, it'll just reduce it automatically. Otherwise, you can just divide, you know? So 196 over, what was that, 686, right? Yeah. So just start dividing it, you know, and just go as far as you can. Just keep dividing, and whatever will come out of the top and the bottom till it won't go anymore. But if your calculator has a fraction mode, you could just enter that in fraction mode, and it'll automatically reduce the thing for you. You know what I mean? Some calculators will. Not all calculators. But like if you have, can I see yours real quick? I notice a lot of people have this one, for example. There's this the TI 30X. One, I see
Yeah.
at least 2 or 3 that have this one. I think there's a fraction button.
Yeah, it's
Yeah, A, B, C. It looks like a big.
Yeah.
Now right here, what's that? Down 3/2 is this A. It looks like a mixed number kind of thing. A, B, C. That's a fraction button on this one. Alina, that one's not going to do it. TI-84, as fancy as it is, it won't do the fractions. It's funny, huh? You think it's so fancy. Not that I know of, it won't do it. So, so this one is so you enter like the fraction. What is it? 196 over 686. 196. Hit that button. 196 button 686. So I just see. Well, I don't know if you can see this. Or I can put it on the whatever. There's a little thing here. Go back. Go real quick. Do that. that, that, that. Hello? Are you there? There. All right, so 196, a little mark, so what I did again, here, let me do it one more time, 196, I go 196, oh, no, that's not one. 196, and then I hit this fraction button right here. This ABC, see it looks like a mixed number kind of thing? Fraction, that means it's making, that's its way of doing a sideways fraction. 686, then I just hit enter. All I'm gonna do is hit equals. Oh, I didn't do 6 today. Well, I'm not very good today. There we go, enter. Boom, 2 7s. Just reduces it automatically, the whole thing. Now, if you have the Casio Natural Display, of course, it'll do everything in the world. It'll solve all your problems on your final exam even. No, not quite that much. But yeah, you just enter it as a fraction, right? You just have this little fraction. Look how nice this is. I could do a commercial for this thing, huh? This thing is very, very user-friendly. They did a good job on this thing. So, so you see you have this fraction button right here. Just hit fraction button. It's ready to, it actually looks, that's why they call it natural display. They're not false advertising. It really looks like what you see on your paper, which makes it very user-friendly. Just type in 196 on the top, and then you put, this is like a mouse thing, up and down, right and left. Hit down. And the bottom was what, 686, 86. And then just hit equals again. Boom. 2 7s. Then they have this SD button over here, which is nice. It changes, you can hit that, it'll change it to a decimal with a bar. Decimal all the way out, hit it again, just keeps rotating through the forms of the answer. Whatever you want. For all the answers. That's the SD button.
All right, I'll buy one.
You don't have to. Yours is good. Yours is a good calculator. Some of them are not, but that one, some of them don't even do fractions at all. So there we go. So some of these you can just do automatically. But not for letters, right? That won't help, you know, so I don't want you to idea, oh, so all the problems, no, just the ones that are pure numbers. Anything with letters, none of those calculators will do it, right? And we're going to get to the letters right away. These numbers are just leading us to letters. So they won't do letters. All right, so reduce, I'll do it by hand. When I look at big old numbers like that, I don't have my calculator with me. I mean, I don't have one that'll do the whole thing automatically. I look at it and I go, well, I don't know. I don't walk around with all the factors of those numbers in my head. But I know 2 goes in. Just start with what you know. I know 2 goes in because they both end even, huh? And so then that'll be, then just use your calculator. 196 divided by 2, it's at 100 and no, 98. Is that what it is? Thank you. And this is 3, I'll just cut the 6.5, the 8.5, and the 6.5. So that's going to be 343. So now what am I going to do? I don't know. Oh, I think 7. Yeah, I just try things. Now I know because I know 98 is 2 times 49, and 49 has a 7. So I know 7, and I just kind of recognize 343. So divide 7 top and bottom, and we get, was it 14? Mm-hmm. Over, I don't know, what's the 49? 14 over 49. 7 one more time. And you get 2 7s. There's the answer. If your calculator doesn't do it automatically. Good, so just keep dividing. Doesn't matter what order. Just keep dividing until it won't go anymore. Like that. Good on that. So let's keep other big numbers. Now, number 5 has the top bigger. That's totally fine. Just leave it bigger on the top. You don't have to do anything special about that. Just reduce it or do it automatically on your calculator all at once. If you want to hit the fraction button and all that kind of thing. So you just break it on down. Yeah, I might do something. Get something going. Let me see. What if I go 1, 2, 3? Oh. Man. Yeah.
Oh, shoot.
So I found one track. It's like on this problem, what you can do is you take 198 divided by 132. Okay, now that's a decimal, right? Now we want a fraction. So here's how you change a decimal to a fraction, hitting that. and it says change to fraction, so hit enter. You're on the right thing right now, hit enter. It means change your answer to a fraction, say yes. Hit enter one more time. Cool. Yeah, so it'll do that, yeah. So I guess there is a way, that way. All right, so did you guys get this one? I just look at it and go, hey, it's divisible by 2, at least. About, that much is clear. Was that 99 over 50 and 56? 100, no, that's not right. It's not 56. What is that? 66? Is that right? Yeah, that's right, huh? And then you look at that and you go, oh, look, you can divide by, I don't know, 3. You can do whatever you want. 33 over 22. Then you can divide by 11, huh? 3 halves. There it is. And it's okay to leave the top bigger. No problem leaving the top bigger. 3 halves on that. Good? Easy enough. No problems. Divide on your calculator. All right, so now x cubed y to the 4th over x to the 5th y to the 5th. Okay, so now, I bet this will be easy for you too. Now we want to reduce this fraction, and it's just letters. So how do you reduce when you've got letters now? Yeah, the powers subtract up and down, don't they? Yeah, and wherever the bigger one is, remember that's where the leftovers end up? We've kind of done this before, remember? Right, so we have x to the 5th on the bottom. That's bigger than x to the 3rd. So those powers are going to subtract, aren't they? So where... and the reason for that is, I want to make sure, I don't want to just give a rule, but what does x to the 5th really mean? Well, it means 5x's on the bottom, doesn't it? And what does x to the 3rd mean on the top? It means 3x's on the top. And so what happens? One of these cancels one of these, one cancels one cancels one. And what's left over? 2 on the bottom. We don't want to show all that every time. It'd take too much time. But that's really what's happening behind the scenes. Is those are a bunch of x's. X to the 5th is 5x's, and x to the 3rd is 3x's. And they cancel like that, leaving 2 x's on the bottom, huh? The quick way is just take 5 minus 3. Just subtract them. How about the y's? Subtract them. Where's the bigger y? Y to the 1, or just regular y on the bottom. Now that leaves nothing on the top, so what do? We always put a 1 when the top of a fraction vanishes. There's our answer. Remember all that from earlier power rules and fraction things? Good. All right. So here is 40 x to the 5th y to the 4th over 5 x to the 3rd y to the 3rd. All right, so try that one. So do the numbers in the front, do the power subtraction. So numbers in the front divide, powers subtract. I think you know. So we good here? So 5 goes into 40 8 times, right? Just divide on your calculator. 40 divided by 5 is 8. And remember, wherever the bigger number is, that's where the leftovers end up. So 40 is bigger, so the 8 ends up there, right, on the top. Okay. And then the 5 and the 3 subtract to be x squared, and the 4 and the 3 subtract to be y to the first. And there's no more denominator at all. So there's our answer, 8x squared y to the first. Is that okay? Do you remember all that stuff? No questions? Okay. Minus 20 c squared d to the, what is it, sixth over 16 c to the fifth d to the seventh. So try that one. So what do we do with the 20 and the 16? What goes into 20 and into 16? 4, right? So you just divide by 4 and divide by 4. So that'll be minus 5 over 4. Divide top and bottom by 4 like that. And then the powers, we subtract, and wherever the bigger is, that's where the answer ends up, huh? So C5 minus 2 is C to the third on the bottom. And D7 minus 6 is D to the 1, or just regular D on the bottom. Huh? So we do end up with a minus 5 staying on the top, don't we? And there's our answer. Is that okay? No questions? All right.
I had a little hiccup on my calculator with this one.
Really?
Yeah, it won't let me put the negative sign on the bottom of the fraction.
You sure you're doing a negative sign and not a subtraction?
Yes,
That's weird.
it says syntax error.
Weird. I can hardly read that. Was it D to the fourth, G to the sixth? F. Right? Yeah. All right. Try. All right. You guys doing okay on this one? So just divide, or you can do your calculator, by the way. You can just put the numbers in if you want. The 33 over the 121, that's what Alex and I were talking about. Right? Don't worry, don't put the negative. Well, Casio Natural Display can handle it, but the TIs can't handle it. So just put 33 divided by 121, and it'll do the numbers for you automatically if you want. Anyway, I'll just do it by hand here. Divide by 3, divide by 3. And so that'll come out 11. And that, what's 121 divided by 3? Oh, not 3. 3 doesn't go into 121. My mistake. Yes, thank you. I was testing you, right. All right, divided by 11, thanks. Okay, there we go. So divided by 11, it should be 3, and this would be minus 11, huh? Then subtract the powers, d to the 1 on the bottom, subtract the powers, g to the 1 on the bottom. Now what happens with those f's? Those are gone, just totally vanish, no f at all. So there's our answer. And you guys know that the minus on the bottom, we could say, or if you did like the multiple choice test we're going to take tomorrow, and they put the minus on the top, that's the same answer, huh? Or even if they put the minus in the front, D, G, right? All those are good, huh? You would grab any of those on the multiple choice test, the practice exam today, the real exam tomorrow, right? Remember a minus on a fraction? Doesn't matter where it's at. Top, bottom, front, it's all the same thing. If there's just one minus sign, it's negative wherever the minus sign is on a fraction. Good. All right, that's that section. We're rolling. Easy, huh? Expanding it a little bit. Okay, so we have 10 y minus 5 over 14 y minus 5. Same thing, they want me to reduce the fraction. So how do you suppose you reduce that fraction?
The same thing. Reduce the same thing?
Yeah, just bang, bang, first off, huh? Those match, they're gone. Just cancel them out. Boom, boom. Now, all you got left is the 10 over the 14. How do you reduce 10 over 14? Just divide by 2. So just divide by 2. Divide by 2 would be what? 5 sevenths, and we're done.
Say if you like multiplied it out, would you still get 5 sevenths?
It might not look like it's 5 sevenths. So if you multiplied it out, you know, you did the 10 boom and a boom like that, you'd get 10y minus 50. And boom and a boom, you get 14y minus, what is that, 70? 70. So then that doesn't really look like 5 sevenths, does it? It is. Yeah, so I wouldn't suggest multiplying it out because it won't look right to you. It is, technically, but you won't be able to tell. Yeah, that's the problem. So, yeah, so we don't want to actually multiply it out. We want to cancel it. In fact, in a minute, what they're going to do is it this section or the next? Maybe even in this section, they're going to actually start here. It's a good question, Kyle. They're going to start here, and we're going to want to go like that. Yeah, they're going to start like this in just a couple minutes. This very section, I believe. They'll start like that, and we'll go, I don't know what that is. So we'll say, hey, let's factor. And we'll factor a 10 GCF in common on the top. Right? And we'll factor a 14 GCF on the bottom, and then we'll go, oh, look at that, they match. Gonzo. And that's actually how we will do it. We'll start here and go like that. Because this is so much easier for us to see. The y minus 5s just cancel. All right. So we've got 6z minus 30 over 7z minus 35. Okay. So, on this one, we have to factor. Right? Because we can't cancel right now. So go ahead and factor the top. Take a GCF out of the top and take a GCF out of the bottom. Factor the top, factor the bottom, and then you'll be able to cancel. You'll have a match.
See, if we weren't factoring, instinct would be 1 over c minus 5.
The 6 and the 7 cancel? They're not powers.
Oh,
Oh, only if they were powers, right? If that was z to the 6th, z to the 7th, powers. Yeah, well, let me talk about that. That's good. But actually, you can't do any of it with pluses or minuses. I'll talk about it. Yeah, I see what you're saying. So let's do it first the way I was saying about take out what's in common. Take out a 6 on the top. All right? Because they have GCF 6. Like that. And what does that leave on the inside? Z, right? 6 times z would go back to 6z. And 6 times 5 would go back to 30, huh? Is that good so far? Now on the bottom, what can we take out of the bottom? 7. They have a 7 in common. She says 7 times what and 7 times what would go back to these guys? Z, and 7 times 5 would be 35. Are we good with that? And then, what are we allowed to do from there? Well, those match, huh? Just cancel those out, and we get 6 over 7. Joel?
I want to be clear, you only factor out that negative symbol when it's the first letter of the first number.
Well said. Exactly right.
If it's that second, you don't factor that.
Correct. Joel's saying exactly right. Is everybody hear what Joel is saying? He's saying only if we have like a minus on the front guy or this front guy do we take out a negative when we do the GCF. Correct. Only when the front is negative does the GCF come out front negative. So just remember, if there's negative in the front, put a negative in the front. If there's not, then don't. Yeah, don't. What Joel's saying is don't worry about the negative in the middle, and he's exactly right. It's only negatives in the front. Well said. Joel, you could teach this class. You say it so well sometimes. Yes, exactly right. 6/7 on that. Is that good on that? Now, Alex's question was a good one. He was saying, let me go back and point something out. He was saying if it wasn't for that, I'm sure he did that correct and knew how to do it and everything, but he was just saying, hey, it almost looks like you could just divide these guys right away. Just divide by 5. What's that leave us? 6, leave us 7 right away. Just do that kind of thing, Well, it turns out, and especially in the next class, get into it a lot, with pluses and minuses, you can't, they glue things together. Pluses and minuses like glue things together, and therefore you can't break the glue bond. So in other words, the 6z and the minus 30 are glued together, and which means you buy the whole package or you don't touch it. Am I making any sense? You ever shopped at Costco or Sam's Club, those big warehouse stores, We have 5 kids, I think I mentioned, so my wife shops at Costco. You buy in bulk, right? You buy one thing. Like if you go there to buy one, tomato sauce or whatever, you can't buy one. It's plasticked to like one other one or maybe in a group of 4. You got to buy in bulk. You can't take your scissors to Costco and cut the bond and say, thanks, I just want one, right?
The other aisle, the scissors are on the other aisle.
Is that what yeah, just go get there's a pack of 7, and you just pull one out and it's all good. Yeah, so that's what pluses and minuses are like in the world of algebra. That'll become really important when things, even at the end of this chapter. Yeah, so as they start giving us fractions with letters everywhere, that's like really helpful rule to know. Pluses and minuses are like glue. They glue things together, which means what? You buy the whole package or you don't touch it. You can't buy part. So that's why Alex's question is a really good one, preempting this idea that because the 6z and the minus 30 are glued together, what that means is you buy the whole package, you cross out the whole 6z minus 30, or you don't touch it. It's buy the whole thing or nothing. You say, well, I just want some of the 30 here. No, it's glued to that. That's why we can't do that. Good question. Because otherwise I'm with you. That looks totally like that's the right thing to do. Why can't we do that too? That's a really good question. Everybody see that? Now, do you see that played out up here? What did I do then? What did y'all do? We all factored out the GCF up here, right? And then look, right here, you say, well, right there you canceled this here. Yeah, see what I did? I took the whole package, huh? The z and the minus 5 are glued together. I bought the whole package. You think, yeah, but you didn't take the 6. Yeah, notice what the 6 is. Times. So he's shopping at Save Mart. You can just leave him, right? The 6 and the 7 you don't have to buy. See, they're not glued. If that was 6 plus or something, then it'd be glued. The whole thing would be glued. I couldn't touch. I'd have to say the whole top or none of the top if it was plussed. But it's not. That's the whole. That's another great reason why we love factoring, because when you factor, then you put a times, and times is separate. You don't have to worry about all the glue rules, the Costco glue rules. That's another reason we're obsessed with factoring. Does that make sense? That way I'm able to say, look, the 6 is separate because he's timesed, and the z minus 5 are glued together. The 7 is separate, and the z minus 5 is glued. So I bought the whole glued package. That's fine. Costco will let you buy the whole package. Right? You can buy the whole glued package. The glued packages are all or nothing. I bought the whole z minus 5 package, the whole z minus 5 package. That's fine. And I left the separate items, and that's my answer. So we'll keep talking about that as we go on. Pluses and minuses glue things together. Make them all or nothing. So that's why we can't do that. Yeah, this is a lot of what goes on in the next class. is these fractions and the reducing of fractions there. So minus 6b plus 18 over 5b minus 15. So for example, let me give you one for instance. Could I just like say, I'm just going to cancel these b's right now, or they match. Why can't I do that? Yeah, because the top is saying, I am a package. I am plussed. I'm stuck together, which means you go like that or you don't touch me. You buy the whole package or none of it, right? All or nothing on that. So minus 6b plus 18 over 5b minus 15. So try it again. So you can't do that. That's a no-no. So instead, what do? How do we get around the glue problem? How do we get around that issue? We factor, don't we? That's why we factor. So on the top, we take out the minus 6. Is that good so far? And then you put inside whatever's going to work. So minus 6 times what? B. And then minus 6 times negative 3. Yeah, good job on the negative. Everybody good with that? Negative times negative is positive 18. Is that good? Negative times negative. Good down there. And then on the bottom, take out a 5. And then what goes on the inside there? 5 times b and 5 times minus 3. That good? We just took out the GCF. Now we're getting around the glue problem. See, now the minus 6 and the 5 are separate, aren't they? You see, when you factor out, you change it to multiply, and now you don't have to worry about the glue rule with him. We can just take the b minus 3's now and cancel them. We're buying the whole package, that's fine. I bought the whole glued package, b minus 3, b minus 3, and I left the parts that are not glued, the minus 6 and the 5, and we're done. Make sense? All those rules coming together?
They just better come together on the final for me.
That's right. I'm sure they will. It's only 2 days away. You won't have any chance to forget this stuff, even if you try
I
it.
already forgot. You know, until you refreshed our memory.
Gotcha. Y squared minus 3y plus 2, y squared plus 5y minus 6. So could I just cancel the y squareds right now? Can I just go, look, I'll just cancel those y's. 2 goes into 6 3 times. It's all totally illegal. Why? Pluses and minuses, which means it's all glued together, which means what? You buy the whole package or you don't touch it. It's all or nothing, right? All or nothing. So we can't do that. That's all craziness. Instead, what do? Factor. That's how we get around the glue problem. We factor. Factoring gets us around the glue problem. Yeah, so don't do that. Instead, factor. I'll erase all that mess. Factor the top, factor the bottom, and you get around the glue problem. Yeah, so factor that top, factor that bottom. So y is in the front, right? This is the old FOIL thing, huh? Right? We're thinking multiply add, right? I can just write multiply add, probably easier to think about it that way. Multiply add. So what multiplies to be plus 2? Good job, good job. Yeah, so it's 2 and 1. And you're totally right about the signs. 2 times 1 multiplies by 2. And how do they add? Remember, let the middle tell you the sign story. How do they add to be negative 3? Both negative, exactly right. Right, because negative 2 and negative 1, either order, add to be negative 3, don't they? And 2 negatives multiply to be positive 2. Is that good on the top? Does everybody see that? Right? They add to be negative. Remember, the middle is what you add to be, and the back is what they multiply. 2 negatives multiply to be positive. You got all those rules down real well now, right? 2 negatives multiply to be positive, but add to be a bigger negative. No?
I don't even know what to do, but I do know.
All right, and then on the bottom, so y is in the front again. Oops, that's supposed to be a y there. And then you're looking what multiplies to be negative 6 and adds to be plus 5.
6 and 1.
Good, yeah, 6 and 1, or 2 and 3. But I think you're right, actually, Jose. I think it's 6 and 1. Yeah, let me show why 2 and 3 doesn't work, because it almost seems right, but you're right. It's 6 and 1. At first, I'm thinking 2 and 3, but it's not right because you think, well, how do you get like plus 5? They'd have to both be plus, wouldn't they? And that won't make negative 6 multiply. See how that won't make them both? You can do the adding one, but you can't do the multiplying one. So it's not 2 and 3. It is going to be 1 and 6, as Jose said. It's going to be 1 and 6. Now, the sign in the middle goes on the bigger. Always on the bigger. Plus 6 minus 1 makes plus 5 in the middle, and they multiply to be negative 6, don't they? See how that makes everything work? Am I racing ahead too fast? That good? Right? Plus 6 minus 1 is plus 5 in the middle, and they multiply to be negative 6. Now that they're all factored, we can do the canceling, right? This and this will cancel, won't they? That's okay to do because I'm buying the whole glued package, right? I'm buying the whole glued, bless you. I'm buying the whole glued package there. And glued together. I buy the whole glued package like that. What does that leave us with? Y minus 2 over y plus 6. And we're done right there. Is that okay? Questions on that? Why at the end, why can't I cancel those y's? They're glued together, huh? So it's no right. So that means if you want to do something with the y minus 2, you buy the whole package, or you don't touch it. Does that make sense? And I can't buy the whole package, so I don't touch it. Right? Everybody getting that rule? Does that make sense? Why we can't cancel those y's? Right? That's what the pluses and the minuses do. They mean you buy the whole package, or you don't touch it. You can't take just the y on that. Right? That good? It's always what I'm telling my daughters. They either buy the whole package, the young men, or they don't touch you. It's marriage or it's nothing. That is, I tell my girls, which they heartily agree, for which I'm thankful. I'm in that zone now where I've got teenage daughters, and young men are coming around and interested, and so that's always a little tricky. We were at a restaurant the other day. My wife and I said, "Hey, we need to take the girls out, my 17 and my 19-year-old girl, and talk about boys, because there's this one boy issue," which I greatly approve of, actually. I told one of my daughters, I heard this one young boy was interested, and I said, and I heard my daughter was kind of like, "Yeah, I don't know." And I said, "Well, if you want my advice, if that boy's interested, be nice. I like that boy. He is a nice young boy. He is mature. He has got his act together. That young boy will be a boy that will be great one day." It's hard for them when they're young. They just think he's just a boy. But he's headed well. He's headed well. I like his family. Anyway, so we went out to talk about that at a restaurant. And then there's this other young man at the restaurant, this waiter guy cruising around, comes by a couple times. My wife leans over to me and goes, "That young man likes da-da-da." Because the other day, I guess my daughters come into that restaurant on their own a lot, and he said something and then met her at the rodeo, or then approached her at the rodeo. I'm like, "Really? We're here to talk about another?" And then he was like circling like the restaurant like 27 times and giving every time my wife dropped it out, he's right there. I'm like, my goodness. All right. My daughter's faithful, giving the right. She's giving the right signal. No eye contact. I'm a good girl. Don't lead boys on. Just let them know. No, I'm actually here to talk about another boy. I'm not looking at you. Anyway, it's just tricky issues when you got the teenage daughters. So I don't want them to marry somebody they're going to regret. All right. So let's try this one.
You're about ready to sit for a gun, aren't you?
I actually feel bad for the young man. I think it's hard for the poor young man. I don't know. My wife and I always go back. My wife always acts like, "Oh, it's so easy for the guys." I'm like, "No, it's not." My daughters are little snobs, and they just act like they're all that. Take them and leave them, and I don't know. I feel compassion on the poor young man. My daughter broke up with this one young man, my older daughter, a year ago, and he was actually Mr. Cool. Like, everybody liked him, and then she dated him for a while, and then she said, "Yeah, he's not that mature. I'm done with him." I felt bad for him, and my daughter's like, "Dad, you're so nice to these guys I break up with, And like, I feel bad for him. He's a nice young man. He's immature." My daughter's like, "He's just immature." Oh,
You're never gonna
girls.
see him again. That's when you're nice to them.
Well, I like him. He's a nice young man. I feel bad for him. He was really nice. But anyway, my daughter's a little snobs a little bit, I think. So. So try that one. Factor the top and the bottom. Yeah. You gonna try that one? Yeah. All right, how we doing there? Multiply, add, what's in the middle is a +1. Like that, right there. Multiply to be -6 at the back and add to be +1 in the middle. So, couple of y's like that. Okay, so what multiplies to be 6 at the back? What times what is 6? 3 and 2. 3 and 2 make 6. And then how do you get the middle to be +1? Yeah, the sign in the middle goes on the bigger, huh? Plus 3 minus 2, good so far? Sign in the middle's on the bigger. All right, and then on the bottom, y's on the bottom. And then what multiplies to be 10? 2 and 5, 5 and 2, either order, yeah. And what signs do we need to make minus 7? Both negative, like that. And that does multiply to be positive 10, huh? Like that. Is that good so far? And now, boom, they just cancel, huh? So we have, and you don't, y plus 3 minus 5, you don't even need the parentheses anymore because there's nothing to separate it from anymore. It's just straight like that is good enough. And there we go. Just like that. It's all good there. Questions on that? All right. There.
You're gonna love number 10.
All right, b minus 7 over b squared minus 16b plus 63. So try that one. So factor that bottom, 2 parentheses. B is in the front. And you're looking for two things that multiply to be 63, add to be minus 16. So what times what is 63? 7 and 9. And then what signs do we need to make that minus 16 in the middle? Yeah, both negative, huh? And that will multiply to be positive, won't it? 2 negatives multiply to be positive. We good there? Use your calculator if you're rusty on some of those, those numbers for 63 and stuff like that. Okay, and then now the b minus 7's cancel. We're taking the whole glued package, so that's fine to do. So there's nothing left on the top, so it's a 1, huh? And the bottom, you don't even need the parentheses anymore because there's nothing to separate the b minus 9 from anymore. So it's just like that. This getting comfortable? It's making sense? So it's really about factoring, isn't it? See how really, if you're a good factorer, this is just 2 factoring problems, right? Factor the top, factor the bottom. Well, just the bottom on this one. That good? Should we move ahead? All right, let's try.
Picky on how you put in an answer.
Is it getting picky? P squared minus 81, P squared minus 81 over P squared minus 18P plus 81. So try that one. Factor the top, factor the bottom. So it's two factoring problems, basically. So that top factors as an FL, doesn't it? Right? A difference of squares, as Joel reminded us this morning on the top. So it's an FL. And then what times what is 81? 9 and 9. Makes 81. Now, and then what signs do we need to make minus 81? 1 plus 1 minus. 1 plus 1 minus to make minus 81. Like that, good. And then on the bottom, what multiplies and adds? So we're going to have 2 parentheses, and that's going to be, how are they going to multiply to be plus 81? Yeah, both negatives, huh? To multiply to be plus 81, and then that'll add to be negative 18. Good with all those signs and everything? And then these guys will cancel. And so what are we left with? P plus 9 over P minus 9. And then that's it. I can't cancel those P's, huh? Or the 9s, because it's glued, package deal, buy the whole thing or nothing, exact match or nothing. And we can't take anything. Good? It's all making sense on that? All right. CG minus CP minus 3G plus 3P over CG minus CP plus 3G minus 3P. Okay, so we can't cancel stuff right now. We've got the loose horses, right? Basically, that's the truth. When you get those pluses and minuses loose, it's the glue thing, the Costco thing, you got to get them all corralled. Got to get them all factored. So factor the top factor. Remember how we do 4-termers? Remember what we learned about how you factor 4 terms? Yeah, first 2, last 2, grouping, 2-2 thing, yeah. That's right. And remember when you do that, you're looking for a match, exact match on the 2 parentheses. So try that, be careful with that. So go ahead and do the bottom. If you haven't done the bottom all the way, finish the bottom. It's the same kind of thing. 4 terms, do first 2, last 2, take out what's in common, and then, bless you, put them all together after that. So at the bottom, take a C out of those first 2, and then the back 2, take out a 3. Good so far? And see how they match? G minus P, G minus, the parentheses always match. When you do the 4-termers, the 2-2, they match. Gotta match, exactly. And now, what do they both have in common? Parenthesis G minus P, remove it, bring down the C plus 3, huh? Getting more and more comfortable how you do 4-termers? Does that make sense? So that goes here. G minus P, C plus 3, and then they cancel. Right? By doing all that factoring, we got around the glue problem, huh? And we can separate them. And so what is then our final answer? C minus 3 over C plus 3. And we can't do any more, can we? We can't cancel these C's or these 3's. Why not? Because they're glued together. Meaning you buy the whole package or you don't touch it. It's glued. Say, well, I just want the C. No. It's all or nothing. It's shopping at Costco. You buy the whole package or you buy nothing. That's the deal. Pluses and minuses, glue them together. Good? Is that making sense? It's a good little review for factoring, too, before we do our practice test and our real test. Because these are basically factoring problems, aren't they? No questions? Is that okay? All right, so 1 minus z over z minus 1. Let me write it this way. It's called the turn around rule. We need a separate special rule called the turnaround rule. Basically, it goes like this. When the letter is subtracted at the back, like 7 minus x or something. So when it's got to be subtraction. If it was adding, who cares? Adding, you can flip the order all day long. Nobody gives a hoot, right? Doesn't matter at all. But if it's subtracted and the letters at the back, we don't like that. We're used to the letters being in the front, huh? So when the letters start back, turn around with minus 1 in the front. In other words, minus 1, x minus 7. Does that make sense what I'm saying? That's called the turn around rule. We're going to need to use that a lot. So when they give you some kind of expression with the letters subtracted at the back, flip it around and put a minus 1 in the front. Why? Because that's the same thing. It just looks different, and it's much more convenient for us to work with. Let me prove it is the same. Let me prove that it is the same. Prove what is the same? Prove that 7 minus x is the same as minus 1 x minus 7. Those are the same thing. How do you know? Let's distribute. Boom, boom. Minus x plus 7. Is that the same as that? Are those the same? Yes. The signs in the front of the players are the same. Remember, order doesn't matter. Signs in the front matter. What's in front of this x here? Minus. What's in front of this x here? Minus. What's in front of this 7 here? Nothing. Plus. What's in front of this 7 here? Plus. Same. See how that's the same thing? When you flip the order and put a minus 1 in the front, it's the same thing. Think about it with numbers. Let me just show you with numbers. How about if I take, like, I don't know, 6 minus 2? What is that? Well, it's 4. What if I switch the order and put a minus 1 in the front? It's still 4. See? It's minus 1 times minus 4. It's 4. See how this and this and this are all the same thing? With numbers, with letters. Letters are just numbers I don't know. So whatever's true with numbers is true with letters, right? You see how it's the same? Whenever you switch the order but put a minus 1 in the front, it's the same. Because what happens when you trade the order of subtraction?
It changes the value.
Changes the sign of the answer.
Oh.
Only the sign. Am I talking too fast, giving too many examples too quick? So let me slow down a little bit. So what I'm saying is when you have an X or any letter subtracted at the back, flip it around and put a minus 1 in the front. Because we like those X's to be in the front. It's just easier for us, just for our convenience. Flip it around and put a minus 1 in the front. Why? Because that's the same, really. Prove it with numbers. One more time. Think about numbers. If you take 6 minus 2 and you flip it around, 6 minus 2 is 4. If you flip it around to be 2 minus 6, what's 2 minus 6? Negative 4. So you see how when you flip it around, it's the same answer, it's just negative now. So if you also put a minus 1 in the front, it goes back to be the same, doesn't it? That's what we're really doing. That's what that trick is really doing. It's saying flip it and put a minus 1 in the front, and it's the same then. You've made it back to the same. So that's a trick we'll use a lot. It's very convenient for us. Let me get rid of this little prove it stuff. I just wanted to show you there's a reason for it, not just craziness. Okay, so now let's actually do it. So which one has the letter subtracted at the back, top or bottom? The top does. So I'll turn around the top and what? Minus 1 in the front. Good so far? So I turned around the top. The bottom is fine. The bottom I'm happy with. It already has the letter in the front. But I didn't like the letter in the back on the top. We don't like letters in the back. So we flip it around and put a minus 1 in the front. You can't just flip it around. That'd be illegal. You've changed it. Right? If I just took 6 minus 2 and said, well, I'm just going to make it 2 minus 6, that's all the same. No, it's not. Now it's -4. It was +4. That's not the same. But if you also put a minus in the front, now you fixed the negative problem. And it is the same, right? That's the idea. Now it is the same. So since I turned it around and put the minus in the front, it's okay. And now these cancel, huh? That's why it works so well. It lets them line up and cancel. What are we left with? -1. All of this is a fancy way to say -1. Is that making sense? Leo?
So on the second step, we wouldn't distribute that -1 into it turned that into -z, +1?
Oh, good
You
question.
would just do that to cancel them out? basically?
Yeah, I don't want to do that because that would take me right back to where I was. A good question. If I distributed that, I'd get -z + 1, right? If I distributed that, and you see that's the same as this,
Oh, okay.
just different order, but the same. Yeah, so I don't want to. That would be undoing what I just did. Yeah, I don't want to do that. Yeah, good question. All right, so yeah, I don't want to distribute that. Just want to cancel. So we're left with -1. Good on that? Shall we try another one? Or they're going to throw a lot, like we saw 4 of these at us now, with this turnaround -1 thing.
Need to save that so that we have it. You know how it goes, if it goes too long, it doesn't.
Oh, you get nervous about that?
There's
Yeah, you know what,
one on there I want
It's over one.
to watch.
I know. I'll try. How about that?